Today we're going to be graphing exponentials and log functions. Now, we kind of got pushed back a little bit. If you were gone Wednesday or Thursday, you did not miss anything. We didn't do anything Wednesday or Thursday because... No, we're going to do notes today.
Today is Friday?
Because of AP testing. So, today we are going to do 11-3. And then next week, we will do 11-4. Then we'll do 11-5, which gives us Wednesday and Thursday to review. And then finals start on Friday. I will have the review for you if you want to get it on Monday, though. All right, so I will have the copies made already. But you'll only have 2 class periods to actually be working on the review before the final.
Is the review a grade?
No, the review is not going to be a grade.
Does your final contribute to your grade? So if I
Yes.
don't do it,
Unless you're exempt.
Oh.
All right.
I'm exempt without the excuse.
Because we're a little close on time, we're going to just kind of do the basics of graphing exponentials and logs. We could get real involved into this and it could take 2 to 3 days, but we're just going to keep it simple. I made a poster over here, so there's stuff that you don't even have to memorize some of this stuff, so I'll refer to this throughout the notes today. All right. First thing, we're starting with exponential functions. You need to know that exponential functions have horizontal asymptotes. Exponential functions have horizontal asymptotes. It's something that you just need to know. An asymptote is a line you can't touch or cross. So it's kind of like your boundary line. You cannot touch it or cross it.
Sorry, can we interrupt it?
No.
Is there a better time?
Can you come back in like 20 minutes? Okay. All right. For this first part, I'm going to do this first one in the calculator to show you how to plug it into the calculator. But then the rest of the day, I'm going to kind of focus more non-calculator stuff. I'm thinking at this point we know how to plug something in the calculator and graph it that way. So that's why I'm just not going to dwell on it. If I were to plug 2 and I want to raise it to the exponent, you're going to press this button right here. This guy right here, this little caret symbol. And you're going to put x in the exponent. So then I get a graph that looks like this. So looking at this graph, where is your horizontal asymptote at?
0.
At 0. So your horizontal asymptote is at y equals 0. For the domain, how far left are you going? Forever. And how far right are you going? Infinity. There is no boundary to the right, so you are going forever to the right. Remember, the boundary is horizontal here. So for the range, how far down are you going? 0. Is that going to be a bracket or a parentheses?
Bracket.
Right, parentheses because there's no point. Only points get brackets. There's no point at 0. It's an asymptote.
Oh.
And then how far up do you go? Infinity. If you wanted to get a table of values, Control T. And you can fill your table out. So 0.25, 0.5, 1, and then 2, 4, 8.
Where's 6?
Is it multiplying by
Is it x to 16? I guess 6.
It's 2 raised to an exponent. So like 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4, and 2 to the third power is 8. All right, and so to sketch the graph, it looks something like that. All right, so plugging in the calculator, you should be able to do, you can get the table of points by Control T.
Question.
Yes.
Are we going to have to draw the graph on this test?
Yes, drawing, but it doesn't have to be like exact.
Okay.
You know, I need it to be the right shape, but I don't really I'm not going to be like staring at everybody's and trying to find your points. 40 questions, all multiple choice, all calculator.
40.
No, 40. All right, number 2, I do want to switch number 2 up. Change it to y equals 1/2 to the x. All right, the reason why I want to graph number 2 is because I want you to see what a decay looks like. So because this 1/2 is less than 1, this is a decay, whereas this previous one, 2 is bigger than 1, and so then this is a growth. And you're growing. Does that make sense? So all this other stuff is going to stay the same, right? Nothing else changes except it's decaying. So your asymptote is still going to be at y equals 0. Your domain is still going to stay the same, and your range is still going to stay the same. The only thing that's different is instead of my function growing, I need it to decay. So we are going to start big and get smaller.
Wait, why is the asymptote on here?
I'll explain more where the asymptote is in a little bit. So growing, you're going to grow up like a tree or a flower. All right, it gets bigger. And then decaying, I have my tree or flower, and it's going to die.
Oh.
Okay, that's how I can remember, I guess. And if you look over here at my poster, I have a growth and I have a decay. So you know what the shape looks like. So growing goes like this, decaying goes like this. Okay? All right, let's go down to the table. The table is going to mean the same thing it has meant all year. Bless you, bless you. So bigger than 1, it's going to be a stretch. Less than 1, it's going to be a compress. If it's negative, it's going to reflect. The C value will go right and left. And the D value is going to go up and down. And the up and down shift is what's going to tell me the asymptote, the horizontal asymptote. Because if you think about it, horizontally, if I were to shift it up and down, it's moving the horizontal line. Does that make sense? If you have a horizontal line and you're going left and right, your line is not moving anywhere. Does that make sense? So, because your asymptote is a horizontal line, so if you go left and right, your asymptote is staying at the same line. But if you go up and down, that's where it's shifting. So the up and down shift is what's going to tell you your asymptote.
So the horizontal asymptote number 4 be -3?
Yes. So on number 4, we are first going to plot our asymptote, which is the up and down shift, and in this case, it's -3. So your asymptote is at y equals -3. Okay, and now, I am not concerned about the some of the other translations. Remember, we're going to keep this simple. So I want to know 2 things. I want to know, is it being reflected? And I want to know if it's a growth or a decay.
No, it's not being reflected.
So,
Yeah, it's a decay.
okay, not being reflected because there's no negative sign. And now for the growth and decay, you have to look at the B value, the value with the exponent. So which one of these, the 1/2 or the E, which one is with the exponent? The E. So the E is going to tell us growth or decay. Is E bigger than 1 or less than 1? What did you say? Greater than 1, right? What is E close to?
10.
Not 10. 2. Very good, 2. So E is really close to 2, which means it's a growth.
So this E is 2.
Yep. All right, so we don't have a reflection. All we have is a growth. It's going to look like this. All right, so no reflection. It's going to be on top here, and it's going to grow. And now we can do domain and range. So what is the domain? Good. Negative infinity, positive infinity. For the range, how far down am I going?
-3.
Very good. -3. And how far up?
Oh.
Infinity. There's no point at -3. There's asymptote. All right. Any questions so far? All right. Hop over to number 5. So start with the asymptote. Where is my asymptote going to be at? At 4. Very good. Horizontal asymptote is going to be at 4. 1, 2, 3, 4.
Are we doing them back today?
Uh-huh. Okay. Is it being reflected?
Yes.
Yes, it is. This negative sign means reflected. So because it's being reflected, I know it's going to be down here on the bottom because it's going to get flipped. All right? Now, is it a growth or a decay? It's a growth, right? Because the 2. So it is a growth. So it's being reflected. It's down here on the bottom, but it still is going to grow. So it is going to grow negatively. It's going to grow kind of like debt, right?
Oh.
Our national debt really is exponentially going to grow, but negative.
No. That grows exponentially.
I don't know, actually. I know we have a lot of debt. and-
What if it? Why can't it go the other way?
Which way? This way?
No.
This way?
Look at me. Look at what I'm doing. Why can't you just flip it?
This way?
Yes. Why can't it go that way?
Because it's not growing.
Oh, okay. I'm done.
That's decay. If you were paying off your debt, maybe.
Oh.
How do you know I'm in debt?
That's like the only example I can think of. All right, the domain, negative infinity to infinity. Right, you're going left and right forever. Going. And then how far up? 4. So range is always down, then up.
There's a bag.
There's a back.
Do we have a practice?
Yes, you do. All right, flip it over. All right, the backs we have log functions. All right, so kind of the same thing. I'm going to graph this first one to show you how to graph it in the calculator, and then I'm going to kind of focus more non-calculator. You do have 2 log buttons. They are here and here. You see them in yellow? So yellow log and then yellow ln. What is the understood base for an ln?
No. Wait. Yeah.
E, very good, E. So the understood base for an ln is E. What is... Yeah, yeah. And then if your log doesn't have a base, what's it understood to be? 10. Right.
Okay, I'm down.
All right.
But it's spelled out log, it's 10.
Yeah. So on number 6, it does give me a base though. It's a 2. So here in this little box, we're going to put 2. And then in the parentheses, we're going to put X. So this is what my log function. Right. So logs are going to have vertical asymptotes. And in this one, it is 0.
So an exponential can't have a vertical asymptote?
No.
Okay, yeah. That's why.
All right, for the domain of this log, how far left are you going? To 0. And then how far right? Infinity. And then for the range, how far down? Negative infinity. And then how far up? Infinity. Very good. I'm not going to worry about the table. I'm sure you can do that. So it goes like that. Okay. I want to show you a decay with the log. So we're going to change number 7 too. We're going to turn it into a decay. So it has a 1/2 there. So give it a base of a 1/2. So we can get a decay function going on.
She just said a bad word.
All right. On your practice, on your test, I don't think you actually have for the logs, but I do want to show you what it looks like. All right. I just want to show you what it looks like on the graph. So if you were to have a decay, you would start close to the asymptote and you would then grow. So it's kind of backwards. So this one you're growing this way. This one you start close and kind of grow negatively. So they're kind of flip-flopped. But you don't have to worry too much with the decays with the logs. You're going to mainly be given growths. Table of values here. We can fill this out, yes. Stretch, compress, reflect, and then right and left, and then up and down. And now because you have a vertical asymptote, your right and your left shift is what is going to tell you the asymptote.
The asymptote.
Yes, that.
So that's like the number 9.
Close. What do you have to do to it? Because it's inside.
What do you want for clear? Negative 4.
Yes. So number 9, your asymptote is going to come from this guy, but it is still on the inside, so you do still need to switch the sign. It will be -4. So 1,